Welcome to a new video in my home automation series, and today I'm reviewing this COFSI 306L three-phase energy meter. It's not just a simple energy meter, it has a lot of additional functions, protection functions, and some miscellaneous interesting functions which I haven't really seen from an energy meter. And it also has a built-in relay, so it can be turned on and off. So, quite a useful feature. And I did a live stream on this about a month ago, a little bit more than a month ago, where I couldn't really get to all the functions because I couldn't really figure out how to communicate with certain parts of it. And then one of the viewers suggested the solution. And if you specifically care about that, it's Modbus function 16. But at least now I understand fully how this device works. I can access all the features. So that's what we are going to review today. So just to summarize this device again, as you can see from the connections, it is a three-phase energy meter and also built-in contactor and then protection device. So you can tell that it's a three-phase by, the 4 different connections. So you have the incoming neutral and the ABC three phases coming in from the top and then leaving from the bottom. So you just wire in circuit and then you have a nice screen where it shows you already a lot of information. Let me turn off the light. So we can see this a little bit better without the light. So by default, you see the three voltages, the three currents, and then the kilowatts on each of the three phases. And then you can see an accumulated kilowatt hours. You can see a frequency and you can see a temperature because it has also a built-in temperature sensor. And you can change some of these screens. So for example, I can cycle the last column to show different things. So either power factor or kilowatt hours. And I can also cycle these last screen, so I can show the energy usage for the 3 different phases or all 3 phases together. And then on the M, I can access some of the functions, and I already show you this on-off button, which turns the whole output on and off. And it is rated up to 83 amps, but to be honest, it is a fairly small unit. It is a 4-DIN wide unit. I don't think it should really be switching 84 amps. Probably the only thing which is sort of like 84 amp compliant is that the huge terminals on either side. So yeah, I will probably use it in residential or commercial settings up to the certain things like 16-20 amps. I haven't taken it apart, but just from the size of it, it doesn't look like a huge 80-60 amp contactor. And by the way, the relay inside is a big latching relay. There is a satisfying clunk whenever you turn it on and off. That's good. Of course, the relay is not energized all the way through. The unit is powering, the device which is connected here. And just to show you the whole setup, so I have the unit, and although this is configured, or this is intended for 3 phases, just for the testing purposes, as you can see, I have a single phase in, so the neutral is connected to N, and I loop the phase into both the ABC output, and I just have some random stuff connected to the output using these pigtails, nothing like that. And then these wire is the Modbus wire, which is then connected to the PC, so we can see how it behaves when we are communicating with this unit over Modbus. And the big selling point for this unit for me, it's communicate over Modbus, but we are going to see a little bit later on that actually there's 3 different versions. So there is a Wi-Fi version and there is a version with no communication at all. And I also showed you the contactor functionality, but also it has a lot of protection features. So you can configure it to trip the output, so basically turn off the output if there is an overvoltage, an undervoltage, or overcurrent, an overpower, or a voltage imbalance, or a current imbalance, or if there is an over temperature as well. So I think it is ideal to protect certain devices, for example, motors, pumps, and it is not really an expensive product. And also I wanted to show you the listing quickly. It looks like that this particular product is not sold through the manufacturer, but it's more like, all sorts of generic suppliers and shop traders are selling these products. So you will find loads of listings, and they go around like this $33, $35 at the moment. So I picked one of the listings because actually this unit was purchased by my father-in-law, so I don't remember what listing he used. So I picked one which is sort of like like the medium price. Sometimes you can find listings that are more like in a 20 something dollar range, but they usually have like a $9 or $10 shipping. So, you know, always look through, you know, which one is the best. Sometimes you have ones that are in the choice, or maybe you can get one of them a little bit cheaper with coins. So yeah, there are a lot of options. I'm going to include one of them, which, you know, looks like in the medium, and, you know, it's in the super deals at the moment. And as you can see, these are the 3 different variants. So that's the variant, the 306L, which doesn't have any data connection, so you can only use the screen to read the data out. And then we have the L version, which is the Modbus. That's what I'm going to review today. And there is also a WF version, which works over Wi-Fi and Tuya. So if you want to integrate it in the Tuya ecosystem, you can do that. And for this unit, well, actually, let's look at the documentation. I have 2 documentation that you will find in the video description below. The first is the basic documentation, which I was able to get from any of the sellers. So that's really easy to obtain, but the problem is that it doesn't really talk about, for example, the Modbus functionality. So you can see the main specs here. Oh, it's actually up to 80 amps. And I thought I have a version which has English as well, but maybe it's not this one. Oh, I might have just auto-translated this. But it goes through the various settings, how you can configure the device, the protection settings for this device, and you can do it using the screen itself and the buttons. But what we are going to do, and I'm also going to show you how you can do it over Modbus, because, you know, if you pick the Modbus module, you probably want to use it over Modbus anyway. But everything is nicely documented here, and also at the end you also find some screenshots how it looks like in Tuya, and it looks like it's, you know, even the Tuya function is fairly comprehensive. You can get like all the usual schedules and timer functionality, but then on the on the consumption screen, you see that you have all the different figures, and you also get some nice graphs of the let's say the power usage and some of the other, I mean, probably not all the metrics, but probably, you know, kilowatt hours and the energy usage. And I assume that there is also a lot of the English version is here, and I assume that there is also a lot of trigger options available in Tuya for the various, you know, voltage, current, power, and whatnot. One additional setting, I would say that this is a single direction meter, so it doesn't do import, export energy or bidirectional measurement. So it's really designed to measure and protect, I would say, probably like a single device or a group of devices. So if you need in a house where you have solar and you want to look at generations, then that's not the product for you. Okay, let me quickly show you the screen as well. So we already mentioned how the screen looks like, and probably as I was scrolling through the documentation, you could see that you can get into the settings by holding down on the M button, and then you can cycle through the settings using the or the changes using the plus minus button. So 0, 1, so you always have this number here. So 0, 1 is the over voltage protection. So it will trip the breaker when the voltage exceeds 275 volts. And then 0, 2 is the under voltage protection. And then you have over current, and then you have over power. And then you have the energy, you know, sum for all the different phases. 06 is a simple timer, so you can set it up to, you know, turn off after 1 hour. You have a temperature protection as well, and you have a voltage imbalance, so that's 0, 8, and then you also have current imbalance, and 0, 10 is the, this one is the screensaver timer, and you also have a timer reset. So that measures how much time has been, the output has been on, and you also have a power reset. So you can access these functions. And page 13 is the reset, factor reset. So if you want to change any of the values, you have to long press the M button in order to save those. Oh, okay, sorry. And then 14, this is the Modbus communication. So the station ID is, or the slave ID is 01 at the moment, and then we're back to the first screen. So this is how you do the settings in the app, and then we are out. And actually I want to show you one thing. So let me just go back to the settings. So I'm going to cycle all the way to, let me just check the temperature, over temperature. So that's set to 50 degrees. So I'm going to lower it down to, let's say 25. And all the, the functions work like this. So you set a threshold, and then I'm just going to save this by long pressing the M button. And then now I have the temperature sensor here. So I'm just going to hold the sensor here just to warm up the temperature. So I've noticed that the, the cutoff is not immediate. There is a certain amount of delay, and I haven't really figured out how to set this. It doesn't look like that there is a setting for the delay, but now we have gone over the, the protection for temperature. So the output has turned off, and we have a blinking 07 here, which just means that it was turned off. The output was turned off because of over temperature. So it actually is going to tell you why the unit has turned itself off. And I can turn it back on. That's it. These are the main functions. So let's see how it works in over Modbus. And for that, I'm going to change the screen, and oh yeah, it turned itself off. I think it's already, sensing the temperature is very warm. It needs a little bit of time to cool off. And since we are here, actually, I'm going to show you all the different registers that I read. And I just want to point out one single register, which is this one. So that's the register which shows that why the output. So this is the output, which is 0 at the moment, and it was turned off because of the over temperature. So we are going to see in the documentation how this value is created. And by the way, since we are talking about the documentation, I just want to show you the other documentation which I prepared, and I'm going to share you in the you will find a link in the video description. It was really hard to get because, as I said, I couldn't get a hold of the manufacturer. I could only get hold of these traders, and they had no idea what I'm talking about because they are selling like, hundreds and thousands of products. But I managed to get it from one of them, and it was in Chinese, so I did the most translation by Google, and I tested it. So I think I have a very good understanding how this actually works and how some of these registers are used. And you see that we have a lot of registers which show all the measurement data, and then we have a couple of registers that we can also change in order to set the protection values or some of the other functions. Okay, so cool. Let's just go back to the Modbus function. So at the moment, it shows that the output is off, and it is turned off because of the overprotection. So let me turn it back on, and yeah, the temperature has gone down to 22 degrees, so it's not going to trip again. And so now you can see that the reason is 0, and then we have the output is on. But let's go back and then look at all the different functions. And maybe I'm just going to do like this so we can have a side-by-side view. And it looks like that the documentation starts listing all the registers from register 12. So I'm not really sure what's really stored below that. I couldn't really figure out these first 12 registers. And especially these values seems to be a little bit static. So it could be some reference to firmware version or something like that. But you can see that from register 12, we store the baud rate, and so the high bytes are the baud rate and the low bytes are the communication addresses. And actually, I think, for me, I usually just change the communication setting. I just usually change the station ID, and the communication settings I just usually leave it on default. And by the way, we are at the moment using 96,000 bauds, 8 data bits, and no parity, and 1 stop bit. So that's how I communicate over serial. And then from address 14 we see the voltages. So 14, 15, 16 are the free phase voltages, and you can see that here it shows that they are stored in 1 registers, and you have to divide them by 100. So the actual values is multiplied by 100. So that's how we store 2 decimal places. So 23,266 is 232 volts, 0.26 or something. And that actually corresponds to what you can see on the screen, although on the screen you see just 1 decimal. And in the next 6 registers, you see current. And again, the current is also stored with 3 decimal places, so times by 1000, and they use 2 registers. So you can see So 68 here is 0.068 amps, and 782 is 0.7 amps. That's on phase B, and on phase C we are drawing 0.037 amps. And of course, once you go into the tens of amps, then they will start showing some values in the higher registers as well, because as I said, they are stored in 2 registers. So one register can store values up to 65,000, so that means 65 amps. If you are using it in under, like as I said, a few tens of amps, you will never really get to the second register. And then similarly, we can go through all the other variants, all the other resistors. So you can see that in the next, always in 13, we have total active power. Sorry, not 13, 23. So 23 and 24. So that's the total active power. And then we go into, active powers. So these are the watts, again, stored in, volt amperes, is stored in tens, so 1 decimal place. And we have a total active power, and then also we have reactive power, and we have also apparent power. So these are all the things that are stored, and you can see that they are again stored in 2 registers. Again, if you are using it for lower powers, you will never get to the second register, so they would always store 0. So this is why you see a lot of zeros in between. And in some of the values, we are getting some weird data, and I think that's just down to the fact that we actually have all the same phases are hooked up to each of the inputs. Normally in a 3-phase setup, they would be 120 degrees apart. So I think for that reason, we are getting some these look like minus or negative readings. So if I change the display to signed values, then we will see some negative readings, but again, that's down to the fact that I'm not really using 3-phase power. So you can use it for single phase as well, just to measure 3 different devices, but then some of the values would just not make sense. And then you see we also have power factor, we have frequency, so we can see the frequency is here with 2 digits. You can see the power factors, so 0.6, 0.7, 0.5. I don't see those on the display. And finally, maybe the most important one is at 52 and 53, we see that's the total consumption. So at the moment, I can see the same stuff on the screen as well. So it is 0.19 kilowatt hours across the 3 phases, and that's the value here. And of course, this can go up to a much higher value, so it needs to be stored in 2 registers. And finally, we see another figure here, which is temperature. So that's 21 degrees. And we can also see runtime. So that's how long the output has been powered on, and that's in minutes. So this unit has been running for 72 minutes. And again, this can get up to a much higher number. Oh no, sorry, the minutes is only stored in 1 single register. And then finally, the one thing that I was also showing you before is the alarm marker. So that's 62, which is 0 at the moment. So when the output is off, that's going to show you why the output has been turned off by the device, if it was turned off by one of the protection features. And then this 163 is the output, the actual output. That is on at the moment. And then you can see in the documentation which bit show what protection features kicked in. So during my testing, I've seen only 1 single bit being used, so I'm not really sure why they have used the bit marker here. I mean, I guess why not? But it's really only going to show you 1, because there is one condition with trigger first and trips the output, and that's what it was going to show. So we use the over temperature, which is bit 5, and 2 and a power of 5 is 32. That's why we have seen the value 32 in this register previously when I was testing the over temperature functionality. And that's it. And as you can see, at the moment, I'm using simple Modbus function 03 to read the holding registers, and I mean I can easily read the first 100, but if you need the single registers, then you can just lower this address space and equality to read a smaller subset. And I think in most cases the best is just to read the values unsigned. If you are hooking it to three-phase power, you will not have these weird negative readings anyway. So I think that's safe to use the unsigned version or the display variant. And now we reached the second part of this documentation, where you can change the various settings. And this is where I had issues previously, because I thought, okay, let me change the the overprotection, so 275.1 volts. So you can see that here they are using 1 decimal place. So when you read the values, they are using 2 decimal places for the voltage, but when you set the thresholds, you are using 1 decimal place. So make sure that you follow this documentation, otherwise you would have some real values. And I think there is a validation what ranges of values that you can put. So probably if you put like a really stupid values, like I don't know, 500 volts for the overvoltage protection, it would get rejected anyway. So my assumption was that I can just use the the right single registers to change these values, and this was not working. So if I want to use 63, that's the the turn off the output. I was trying to use that, and it says just illegal function, and that's why I was like, why is it not working? It's clearly, the documentation says that you can read these registers. So after that comment, I tried using the Modbus function 16, where you can write multiple registers, but you can also write a single registers. So let's say if I want to change these, the over voltage protection 275 volts. So if I want to lower it, so that's address 64, and I just want to write a single register, and I want to 280 times 10, and then send, response okay, and now it's 218. And actually, if I change the view, and if I go into the settings, so the first one is the over temperature, and now that has changed to 280 volts. So yeah, that's it. And of course you can write multiple registers. So if you want to reset like all the over temperature, over voltage, then you can do it with one single function, Modbus function 16, but I think in most cases I'm just going to use a single write. And also you can use this to, for example, turn off the output. So that's address 63. So if I want 63 and I change the value, I'm going to put a 0, send, doop. You probably hear the clunk, and now it's off. And I can turn it back on, edit, put 1, send, and now it's on. So as simple as that. Right at the end of the addresses, there are also some registers where you can zero out some of the energy readings and some of the other readings, and it looks like you have to put a certain value into those. And it says this was something that I again got translated from Chinese, only allow single word writing. So you can just if you want to clear these registers out, you only clear make a single write with Modbus function 16. Probably doesn't allow changing multiple registers and these clearing registers at the same time, but fair enough. The only other thing I wanted to show is there is also this countdown. So this is really not like a production functionality, but it's, I mean, you can use it to you can use it as a timer. So that's is address 70. So if I do that, address 70, and if I put like a value of 2, that's in minutes. So what is going to happen is that this has so I put 2 minutes into it, and it started immediately counting down. So now it's like 1 minute and some seconds, and after 1 minute or after 2 minutes, the output just going to turn off automatically. So that's it's not really a protection functionality, but again, you can use it for some sort of automation, and you don't have to rely on some additional logic to turn off the output, but you can just send this information to the device, and it will just turn the output off. So this could be used as a last resort protection. So for example, if you are operating a pump to top up like a water tank, you know that you are not supposed to run it for more than 1 hour. And of course, you also want to rely on some other sensors reading, but let's say that sensor is broken or shows incorrect readings and your function doesn't trigger correctly, but you set a countdown, so you're not going to run the pump for hours and hours, but it's going to cut off after some time. So now we are down to less than 1 minute. So that's it. It's turned itself off, and I get a 06 code here, but that's not really, I mean, I think 06 is, normally there would be voltage imbalance, but that's not voltage imbalance. And if I go back to Modbus, I'm not reading, so let me just go back here. So in this registers, I'm not reading any error code. So you can just see that if it stays 0 and then the output is 0, then it either got turned off manually or the countdown just turned the output off. So that's pretty much sums up the functionality of this device. I really like this inexpensive product. As I said, I wouldn't really use it for the claimed current readings, but for something where, you know, it can measure, you know, all these different usage and energy characteristics, and it has all these also protection functions, and you can just turn the output on and off. I think it could be used in many different scenarios. And again, as I said, it's not really expensive product to purchase in order to protect something. Even if you want to protect a simple pump which costs a couple of $100s, then you can buy this for like $35 and then have that protected, and you know, it's going to trip on overpower or overcurrent, as simple as that. And you can even hook up this temperature sensor, and if the you know, the device is close enough, because this cable is not really long, then you can just you know, trip the breaker on if the motor gets overheated. So there's a lot of different options here how you can use this. By the way, there is a single phase variant available from this as well, which I'm planning to purchase like a unit and then just test it out. I assume it's going to be fairly similar in terms of the functions and the Modbus addresses. But yeah, that's it. If you are interested in this device, there is going to be affiliated links in the video description. But that's all for today. Thanks for watching, and hopefully see you in the next one.